Okay, today we are going to work on how to graph someone's speed or velocity based on a time frame and the distance they traveled at certain intervals during that time frame. So for this activity, there's going to be two sets of data that we're going to work with, and then look at how we can use both the table and the graph to show what someone's speed is going to be. So there's two data sets here. We have walking speeds, which we'll work on first, and then the second set is going to be car speeds. So our walking speeds, the table below shows a distance traveled by a student walking for 1 minute. Make a line graph of the data below. And then we have this nice table that has time in seconds, distance traveled in meters, and we can see for the whole minute, for the whole 60 seconds, they put their time intervals at 10 seconds, so nice regular intervals. And then the distance traveled over that time is a little bit less regular because this is the dependent variable. This is the thing that we're measuring. So we can see that over different time periods, they either sped up or slowed down, but their final distance traveled was 24 meters within that 60 seconds. So there's two ways that we are going to look at this data. So before we do any calculations, because you've been doing a lot of calculations, we are going to first look at how to graph this data. So I'm going to graph it two different ways. Obviously, we are in Google Sheets, so I'm going to be graphing it on a computer, which we are less familiar with probably. And then the second way, if you look here, I'm going to graph it by hand. Really, it's like over the computer. So you could do this on paper. I'm going to do it on my screen so you can see what this graph would look like. But we're just going to make a quick line graph from our data here. So we have our x-axis. Our first column is always the x-axis. And if I didn't say this already, I'm going to do it by hand first, because once I do it by Excel, you probably won't want to do it by hand. It's a little tedious. So here my x-axis has 1, 2, 3, 4, 5, 6, 7 spots on it. So I need to make sure that we can go 7. So we'll see how this turns out. And then we want them to be regular intervals. So I'm just going to do ticks. So we're going to have 0 here. Ooh, I should make that smaller. And then we have 60 here. We have 10. Okay. If this was by hand, this would look a lot better. 30. Did I put too many? 10, 20, 30, 40, 50. And I did. So let's erase that. All right, let's go back and say 60. Oh man. One day I'll be better at writing on here. And then 40 is in here. You get the idea. I hope. Okay. And then up the side, we need it to get to 24. So what I'm going to do is probably, each box is going to be 2. So we're going to go from 0 to 24. So I need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm going to put an extra one just because I don't like my last data set to be, or my point to be at the edge of the graph. It's fine if you do it that way. like it's proper. I just don't like the way it looks. 24. And I'm just not even going to put the numbers in here. We're just going to know that 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. And I'll put the 2 there just so we know that it goes up by 2s. Okay. So now I'm going to graph my points, and I'm going to change my color. And I'll make it a little bigger since I'm just getting dots on here. So I'm going to say at 0, he went 0. Put a dot here. At 10, he went to 5, so that's 2, 4, and then about halfway up. At 20, he went to 8, so 1, 2, 3, 4. And then he went to 12. And then next he went to 17, so that's going to be 12, 14, 16, 17. And then at 50, he went all the way up to 23. And then at 60, at 24, up at the top. Okay, so we have our points. The last thing we're going to do is just put a line between them. I'll keep it red. We'll see how good I do at drawing this line. Probably not great. Okay. Okay, but we get the idea. So this is an okay graph. It's pretty terrible if we look at it, but it shows a like approximation. So we can see he starts out pretty fast, he slows a little bit, but it's a pretty regular pace until the end. That last 10 seconds, he didn't really move that far. He only went 1 meter, about 3 feet in 10 seconds. Okay, so here's by hand, and then we would have to, of course, label. So we want to put time, and then this is going to say distance. Oh man, this is going to be terrible. Dist. Okay. So after that atrocity, let's go over to doing it by computer. So what we're going to do when we graph by computer is we're just going to highlight the data that we want. So highlight the data table. You go to Insert. You go to Chart. Hopefully this is bringing back some memories of the last time we did this. And here we get a much nicer version of that graph I just made. So they have it as a scatter plot. I'm going to make just a couple changes on this that you can make or not make on your graph. That's totally fine. So the first one, I am going to go to my grid lines. I want to have more lines in here to make it clear what these points are at. So if you go down to grid lines, it makes you do by vertical and by horizontal the same way. So what I want to do is for my vertical grid lines, they only have the major spaces. So I want to have the minor ones as well. And then I want to do the same thing with the horizontal. So this puts much better context in there as well. We're going to go count, and let's do minor ticks as well. So now we can actually see every 10 on here. Let's say, I'm actually going to turn that off. Okay, so this looks much more like an actual graph. Okay, so here we are with our graph. The last thing I'm going to do is I'm going to go back to setup And I do want it to be a line graph instead of a scatter plot. And then I'm going to customize my series. And I still want, well, I want them to be bigger than that. I still want the dots to show up so we can see what the actual data was. Okay, so again, this was a very pretty standard, like he looks like he's moving at a pretty constant rate. It almost looks like a straight line until the end. What I want to look at is how we can tell someone's speed from these graphs. So if we look at this, none of this actually says speed. None of the numbers that show up are our speed. The speed is, if we remember our equation, I'll write it here, speed equals distance over time. So if we take our distance number divided by our time number, that's going to give us a speed. So for example, if we want to take our average speed, our total distance, and our total time, here it would be it equals 24 divided by 60, which gives us 0.4 meters per second. Okay, so it would be speed equals 0.4 meters per second is what we end up for our average. So hopefully this whole distance over time should look similar to something that you learned in algebra before, which, if you don't remember, there's one thing that you do on graphs that is your y divided by x, your distance divided by time, is the same thing as rise over run. Oh, don't do that. Okay, sorry, if you put equals, it ruins everything. So rise over run, which is the equation for slope. Slope equals rise over run. So because your distance is your rise, it is the y-axis, and the run is time, that's the x-axis, y over x, your speed is going to be the slope of this line. Okay, so at any point on a graph, you can tell how fast you're moving because it'll have a steeper slope. This is something we touched on before, but I didn't actually make you do any graphs of it. So this is just to look at a quick way that when we have numbers that are really similar like this, the easiest way to tell when someone is moving the fastest or slowest is to look at the slope of the line. So this one's going to be difficult because it's so similar, but you can very vaguely see that this chunk here is a slightly steeper slope. So the fastest time interval is from 40 to 50. And then the slowest time interval is going to be from 50 to 60. So I hope that part makes sense. The fact that the slope equation equals the equation for finding speed is why we can use the slope of the line to find our speed. Okay, so hopefully this one made sense. The second one, I think I'm going to skip doing the hand-drawn graph because this is going to look terrible. But now that you've seen, I did the hand-drawn just to connect it to like the way that we are comfortable with using this. So now we're going to do this second way, this graphing by computer, and then we'll talk about what it means afterwards. So one thing that can be difficult when you're graphing on a computer is that it's very easy to just, press insert chart and then have no idea what that chart is saying because it does it so quickly for you. Maybe not to notice if it did it wrong. When you graph by hand, you kind of have to sit with the information for long enough that, it's clear whether you did something wrong. Like halfway through, you're like, wait a minute, this doesn't make sense. So we'll do some analysis afterwards, but I want to make sure that you actually understand what these graphs are telling us and not just plugging it in and turning it in because you were told to make a graph and maybe it's right and maybe it's wrong. Okay, so this data table, very, very similar, except this time it's the distance traveled by a car over the course of a 3.5-hour trip. So we're going to make a line graph of this data. So we have our time in hours and our distance in kilometers because the car is going to move so much faster than the person walking. So it's good to use your appropriate unit so we don't have gigantic numbers here. So our time in hours, we go, one complication here is that they're not regular intervals anymore, is that they're just random times that we look at our So if we look at our time, our x-axis, one complication here is that unlike our walking speeds that were at regular intervals every 10 seconds, now we are looking at just random times when they pop in. So we have a half an hour, so 0 to 0.5, and then we have 15 minutes, and then another half hour, and then 45 minutes, then an hour, and then half an hour. So this would be something that would be a pain to graph. So I'm not going to put the whole graph on here, but let's just, if we were to try and mark up our x-axis, and you know I already messed up the first one, so you know this is not going to go great for us. Let's say that every 2 lines are a half an hour. So this is going to be 0.5. And now I'm going to stop writing because that's going to be confusing. So if every 2 lines are half an hour, the next line would be at 15 minutes. And then we'd have another 2. And then we're going to go 3 for the next one, and then 4 for the next one, and then 2 again. So it's doable, but it's a little trickier to make sure that you have nice to like have it nicely spaced out and to scale. What we're going to do here is I'm going to highlight this table. Just like before, we're going to go to Insert Chart. Oh, actually, I'm going to go back. The other difficult thing before we move on to actually doing it the easy way is that from here we have an interval from 0 to 246, so a big interval, and some of these numbers are pretty close. So this one here is only 12. So if we were to try and put this on a scale, it would be difficult to get an accurate slope here and still keep everything within a reasonable space on your paper. You know, like if you have small numbers that you're trying to graph and like intricate numbers like 103 instead of just 100 on a scale of almost 250, that's going to be a difficult thing to try and reckon with. So what we're going to do is, now that I've talked your ear off about this, we're going to highlight our data. We're going to go to Insert Chart. And here, just like before, I'm going to put in just a couple customizations to make this a little bit easier. So chart style, okay, my series, sorry. My point size, I'm going to make 0.7. I'm also going to change the color because I hate this color. Okay, and then for my grid lines, I'm going to add my minor grid lines in there. So let's do count, and let's do okay. So now it's going to do every half an hour as a grid line to make it make a little more sense where we're looking at. So the only ones that are outside of it, we know this is 0.75 and this is 1.25 here. So this one again is a little bit of a smooth line, but we can see sometimes where the graph kind of levels out. So here we have a very steep slope at this middle part here. which is going to be our fastest speed, and then our slowest speed at this end here from 3 to 3.5 hours. So almost like that last thing that showed up, which is going, or the walking speeds that they slowed down at the end. So again, I'm not going to go over the equation again, that we have our distance over time, our rise over our run. So again, just looking at the slopes can give us a really quick understanding of where things are going quickly and where they're kind of slowing down. I am going to do one more in here. So let me just copy this. I'm going to make some changes to this data set on a new graph. And I'm going to say, like, let's say between this half hour, between 75 and, actually I'm just going to clear everything out here. And I'm going to say actually half an hour is very quick to make a pit stop. So let's say they went another 60, 140, no, that's too fast, 120. Okay, so after an hour and a quarter, maybe they stop to get lunch. So this 45 minutes here, we're going to stay at 120. So they didn't move. They were sitting at the restaurant, car was in the parking lot. So then at 2 o'clock, or at 2 hours, they're going to go back to their car, drive for an hour. Let's say they get to 180, and here 210. Okay. So now let's just quickly make a graph of this, because it's going to add in one part that I've mentioned before. I know you know this because I make you tell me things over and over. But looking at our graph, the time that they were sitting in the car, and again, I'm going to go to series. We'll change this color to red so you can tell I'm looking at a different one. We have a horizontal line here where we were stopped and didn't travel anywhere. So any time on a distance over time graph that we have a horizontal line, there's going to be a stop period. So the person just stands still. So this is something on that gizmo that I showed you before where we had those two little runners. I'll pull that back up so we can show what this would look like. I'll try and like mimic this graph so we could see how those guys would look. Okay, so here we have our little gizmo, and I am going to try and mimic what happened on this first graph of the person walking. So we're going to go up to 5, and then we went to 8, and then we went to 12, and then we went to 17, and then we went to 23, and then we went to 24 at the end. So I think this is about right. Okay, so let's watch this animation. Get this guy to go. So he slows down, he speeds up, and then he really slows down at the end. So it's just to like visualize what this would look like. Let's do the car speed, the second car speed as well on here. This is going to be a little bit more difficult because I have to do it like to a scale. So I'm going to pretend that everything is like 1/10 of what we did because I used nice numbers this time. So I'm going to go 0, 4, 6, 12, oh, which is the same one. Okay, and here's the one where we stay at 12. So this is going to be a little off because I can't drag the horizontal direction on here. so I can't change the actual time intervals. So we're going to pretend that these were regular time intervals. So then we go up to 18, and then we go up to 21. Okay, so let's start here. Pretend this is a car and not a man. So it speeds up, stops, and goes. Okay, so this is just to show that like what we were saying about the slope and how fast they go is correct, is what it would look like. So what I want you to do today, you don't have to do this third one with me, but make sure you have made the walking speeds and the car speeds, made your graph. The last thing I want you to do is to change the title, because I don't like the automatic titles it gives you. So let's get rid of this. And we are going to say distance walked in 1 minute. Just make it something, it doesn't have to be the same as mine, something that makes more sense than what they're saying. Okay, distance driven in 3.5 hours. And then that's it. Hit submit, and you are done for today.